Welcome back, my dear students. Welcome back. Confirm, beta, everyone. Audio, video, crystal clear, beta. Can we proceed? Okay, Pradeep Kumar. Okay, my dear students. So today I'm very happy to start another new subject in this Crash Come Full course. And as you all know, beta, today we are going to start mass transfer operation. Mass transfer operation. Very important subject, and most of the student feels this subject this subject is very hard, but no, beta, no subject is hard if you are going to study in a sequence manner. Okay, and the same thing you will feel just after completion of this lecture number 1 of this mass transfer operation. And one information for English learners, beta, those who don't know Hindi, so my dear students, whenever I am using Hindi, that means just I am translating my last line just for feeling of Hindi learners. Okay, so Hindi learners की feeling के लिए हम बीच में हिंदी का इस्तेमाल करेंगे, but that Hindi is just translation of my last line in English. Okay, so clearly for upcoming gate examination lectures based on latest revised syllabus and with concepts, ground level concepts, beautiful numericals, new numericals, as well as PYQs. So now we are in lecture number 1, mass transfer operation, diffusion. So one more time, beta, please write everyone crystal clear. But a crash course right now it is open on YouTube, but it's a live open. But once lecture in, then it can private and only available for our paid members. That will be only in Gate Chemic Learning App. So don't miss live. Okay. चलो, वेरी वेरी हैप्पी गुड इवनिंग बेटा, हरित्र, राकेश, प्रदीप, एवरीवन, स्वागत है बेटा आप सभी का. एंड हियर अगेन आई विल टेल यू बेटा, एज ऑलरेडी आई टोल्ड यू दैट आई विल give here full course of mass transfer operation, but in such an optimum manner so that you can say crash come full course, because I am going to take very less time in comparison to my detailed mass transfer operation lectures. So here also I will cover all topics, but in a scientific manner, in an optimum manner, so that we will able to cover complete mass transfer operation in very less time. Okay, so without any delay, I am going to start today's chapter number 1 of this mass transfer operation, diffusion and numericals. So first, beta, a few fundamentals you have to see about this chapter diffusion. Whenever you are seeing, beta, diffusion chapter, then one question may come in your mind, that what is a mass transfer operation or what is a diffusion? Is there any relation between these two, or these two are same? So my dear students, without diffusion you can't imagine for any type of mass transfer. Okay, so you can say that diffusion is the key that by which you can see mass transfer phenomena. Okay, and the basic difference, if you want to differentiate these two, beta, then for diffusion one phase is there, but for mass transfer more than one phase is there, like two phase, like liquid to gas side, gas to liquid side. Okay, driving force, if you want to see for mass transfer and diffusion, so for mass transfer, my dear students, it's a chemical potential, it's chemical potential, chemical potential. And for diffusion, the general driving force, you can say, but a concentration difference, concentration difference, it is concentration, very happy gooding beta, it is concentration difference. Okay, it is concentration difference. But for diffusion there may be some other driving forces that you can write here, beta, like temperature difference, like pressure difference. But as we are chemical engineers, so we will see here molecular diffusion. Okay, we are not interested here in thermal diffusion, in pressure diffusion, etc. That means for our cases, you will see that in most of the questions, or you can say approximately all questions, you will see temperature is not going to vary, or total pressure will also remain constant. Okay, so why? Because we are dealing here not all types of diffusion in our syllabus, as we are chemical engineers, so we will deal which type of diffusion? Molecular diffusion. AD diffusion is also there, but the speed of AD diffusion is very very fast, very high speed, in just a fraction of seconds, or in just a few seconds. But a molecular diffusion is a very very slow process. That's why here we need to calculate. So we need to solve many numericals. We need to solve many numericals. Now see these definitions just for this slide. No need to even read this. But see, mass transfer refers to the transport of mass from one place to another. But diffusion is the movement of solute or a gas from an area of high concentration to an area of low concentration through air, water, or anything, any other fluid. Okay, occurs across a concentration gradient. So here, just in very very short, this कंपैरिजन आई हैड डन हियर इन वेरी वेरी शॉर्ट मैनर. यहाँ जो हमने कंपैरिजन किया है बहुत ही शॉर्ट मैनर में, जस्ट एक आपको दिखाया है. इस तरह से आप चाहो जितनी भी लंबे लंबे आप चार्ट्स को फिल कर सकते हो. नाउ the next thing, my dear students, mass transfer operation. What is the main application for us? Why we are reading this subject? So the main application of this mass transfer operation in separation. In separation, why you want to separate? Because when you are going to produce anything, then many byproducts will be there, also formed along with your main product. So you need your product in pure manner. So that's why separation required. So for most of the separation processes, you are going to use mass transfer phenomena. Like the main aim is to obtain pure products from impure products. Okay. Now how purity we are going to define in an industry. किसी industry में आप purity को कैसे define करते हो? So purity can be defined as the ratio of final to initial concentration. Like suppose you are going to make a liquor, and suppose you got a beer solution in which 5% alcohol is present. 5% alcohol is present. Okay, 5% alcohol is present, and now you are going to concentrate it with the help of many distillation columns, and now you are making up to 95% concentrated alcohol. Okay, alcohol. So here, what is our purity that you got? Final to initial. That means here beta it's 19. Okay, so clearly why purity I'm defining in this manner? Because this ratio is going to define the cost of this separation. Cost of this separation. If more purity, that means higher the cost is there. Higher the cost is there. So you are going to use mass transfer operation here. आप mass transfer operation का use कर रहे हो in order to convert impure products to pure products. अगर आप impure को pure products में convert करने के लिए mass transfer operation का इस्तेमाल कर रहे हो, so clearly if you don't know well this subject, you are not able to do these things economically. आप economically नहीं कर पाओगे यार. You can't able to do these things economically. Okay, so tell me beta everyone, is it crystal clear, my dear students? Is it crystal clear? Sir, can you please increase your speed? Don't worry beta talk. I will increase my speed or decrease my speed as per requirement. Okay, so that all students will satisfied. So don't worry beta, don't worry. Okay, clear beta submarine and everyone? Very good. Now for a chemical engineer, mass transfer is a phenomena which results in a change of composition. Why composition? Impure to pure, 5% to 95%. Okay, or which results in some separation. Which results in some separation. Many chapters you will see like a distillation, extraction, drying, absorption, adsorption, many. Okay, and one more important point here beta that we are not interested in the case of fluid flowing. पानी बह के जा रहा है पाइप से, उसका भी ट्रांसपोर्ट हो रहा है, मास का ट्रांसपोर्ट हो रहा है. When fluid is flowing, the transport of mass is there. Is it mass transfer operation? No. So we are not interested in these type of cases, because these cases you will deal where in fluid mechanics. In fluid mechanics. Okay. Now, modes of mass transfer. One more fundamental is there. Modes of mass transfer. So here you can see I had done this classification as conductive and convective, just like as you had seen in the case of heat transfer operation. आपने heat transfer operation में पढ़ा है. Conductive type of heat transfer in which the place of molecules are fixed and the heat is going to travel with by the vibrations or electrons, with the help of electrons or vibrations of molecules. But in case of convection, convective heat transfer, molecule is going to take energy from one point and now it is going to transport that energy to some other point. That is heat transfer operation. But a little bit difference between these two beta. Why I am saying this beta? See, when you are seeing conduction in heat transfer and in mass transfer, in heat transfer you had seen molecules can't leave their place. Molecules अपना place नहीं छोड़ता रे बाबा. वहां पे कहा हीट ट्रांसफर ऑपरेशन में प्लेस फिक्स होता है, वाइब्रेशन के थ्रू एक पॉइंट से दूसरे पॉइंट पे हीट को ट्रेवल कराता है. बट व्हेन यू आर गोइंग टू सी इन मास ट्रांसफर बेटा, इवन इन कंडक्टिव टाइप ऑफ मास ट्रांसफर, मॉलिक्यूल्स कैन लीव from their place. Molecules can leave their place. Molecules can leave their place. Okay, molecules can leave their place. So this is conductive mass transfer. Conductive or convective, it doesn't matter. In both cases, molecules are now going to travel, maybe by bulk flow and also maybe by both, like diffusion plus bulk flow. Like here, one beautiful example you can see. Suppose one stationary plane I am taking like this. Here I am not taking this example as an observer. That is different thing, and I will discuss that एग्जाम्पल इन दिस लेक्चर आफ्टर फ्यू मिनट. बेटा हम यहाँ कोई ऑब्जर्वर नहीं ले रहे हैं, जस्ट एक प्लेन ले लिया और हम देखना चाहते हैं कि ये मछली इस प्लेन को पार करना चाहती है इन दो केसेस में, तो उस मछली की स्पीड क्या होगी, उस फिश की स्पीड क्या होगी. आई एम टेकिंग दिस एग्जाम्पल एंड जस्ट आई वॉन्ट टू सी द फिश दैट वॉन्ट्स टू ट्राई दिस स्टेशनरी प्लेन, or you can say this plane, how much, in which case it is going to take more time, or at which velocity it is going to approach that plane. वो किस स्पीड से अप्रोच कर रही है. ओके, सो हियर आई एम टेकिंग स्टेशनरी वाटर, लाइक अ रिवर वाटर इज स्टेशनरी. हियर नो, वाटर इज मूविंग वन, फेज इज मूविंग वन, फेज इज मूविंग वन. लाइक इन सी, समुंदर है, पानी बह रहा है, उसमें आप भी कर रहे हो. अरे भाई, समुद्र के पानी में आप नहीं भी तैरोगे तब भी एक प्लेस से दूसरे प्लेस तक पहुंचोगे ना यार. इवन इफ यू आर नॉट गोइंग टू स्विम इन सी वाटर एंड इफ द वाटर इज ट्रेवलिंग, ऑटोमेटिकली you are also traveling now. Just tell me yes or no. Yes or no in comment section, beta. Please everyone tell me yes or no. Are you able to understand what I want to say, beta? क्या आपको समझ में आ रहा है? And also, beta, please tell me, Hindi learners also able to connect na? Sir, how much cost of course, where to connect, beta? Just you have to do WhatsApp on 9451707049. 9451707049. Okay, and you can do call or WhatsApp and just you can ask details of this course there. This time huge discount is going on, so you can ask price or any other thing on that number, beta, and only this number is official one, 9451707049. Okay. Sir, please Hindi language में समझाइए. बेटा many English learners are also our paid members. That's why complete Hindi I can't use English language. So don't worry, beta. I will make you comfortable, and after some time you will also able to feel comfortability. Okay, beta. आपको भी comfortability लगेगी, चिंता मत करो. Just try to focus. Okay. So I had taken this example. Now, suppose the fish is traveling by its own capacity, अपने कैपेसिटी के द्वारा वह ट्रेवल कर रही है, एंड दैट इज एट सम स्पीड ऑफ 2 किलोमीटर पर आवर. 2 किलोमीटर पर आवर. सो Can you tell me at which speed it is going to cross this plane? क्या आप बता सकते हो? Can you tell me in comment section बेटा? सर आ रहा है समझ, वेरी गुड बेटा. Yeah, that's why I told you exam question is also coming English language and English is compulsory this time ना. अंग्रेजों ने आपको जो वरमाला पहना दिया इंग्लिश का, आज तक उससे पीछा ना छूटा है ना छुड़ा पाओगे. So please everyone tell me. Absolutely correct, beta Divyansh. It's a 2 kilometer per hour. But suppose if the phase is also moving at some speed of 5 kilometer per hour, then can you tell me at which speed the fish is going to reach that stationary or that plane? That plane. At which speed? At which speed? I can understand, but feeling is also important. Yeah, beta. Don't worry. You will feel. Once topic is clear, you will be able to feel. बट अगर हिंदी यूज करेंगे देन इंग्लिश लर्नर्स इवन कांट एबल टू अंडरस्टैंड. फीलिंग तो बहुत दूर की बात है. एंड यू विल एबल टू फील, डोंट वरी बेटा. जस्ट आफ्टर सम टाइम यू विल बी हैबिचुअल, बिकॉज आई एम यूजिंग वेरी लेस वॉकैब फॉर इंग्लिश. इंग्लिश के लिए भी जो वॉकैब, जो शब्द हम यूज करेंगे बार बार वो रिपीटेड फॉर्म में होगा, तो आपको इंग्लिश में भी वो फील नहीं होगा. वो खतरनाक वाली इंग्लिश नहीं यूज करेंगे, लाइक आई क्वाइट एस्टोनिशिंग, इस तरह की इंग्लिश यूज नहीं करेंगे. वेरी वेरी इजी इंग्लिश. Yeah, it's 7 kilometer per hour. Very good, fantastic. Now I had taken here one beautiful example of tea. Now just to see here beta, tea example, tea preparation. Champu and changu. Champu and changu, two students are there. Okay, now Champu had taken this tea bag and he is going to place in this hot water. Okay, and now he left it. What he had seen, that now some dark color is going to come from that tea bag, and the process is little bit in slower manner. आप भी ऐसा कर सकते हो. But Changu what had done? Changu is now going to use some spoon. Changu is now going to use some spoon in order to, again here tea bag is present. Suppose tea bag is also here, and now he is using some spoon. If some spoon is there, that means some bulk movement is also there. So my dear students, if some bulk movement is also there, then this is convective mass transfer. But if only and only molecular diffusion in this manner, beta, what does it mean? Here only and only molecular diffusion is occurring. So I hope you are able to understand what is the basic difference between this conductive or in this convective mass transfer. That means here you had seen molecular diffusion like this case. Okay, sir, are you take CRE, IPC, thermo, fluid flow, crash course? Yes beta, all subjects. As you can see, this mass transfer, just I had completed mechanical operation in solid handling too. Okay, in 7 lectures with 241 numericals. Okay, now just focus on this mass transfer lecture beta. Now few more fundamentals I want to discuss beta. Classification of mass transfer operation based on phases. फेज के आधार पे. सी दिस इज डिफ्यूजन. दिस इज अ ग्लास. यहाँ एक ग्लास आप देख रहे हो बेटा, और इस ग्लास में क्या कर रहे हो आप? इंक डाल रहे हो. यू आर गोइंग टू ड्रॉप सम ink here. Now ink is going to diffuse in this manner. What is this? In same phase, both are in same phase now. This and this both are in same phase. So which phenomena is going to occur here? It's diffusion. What is this? This is diffusion. And why I told you that for mass transfer operation, chemical potential is driving force. Suppose this is your H2O plus sugar solution. Here 10% sugar is present. Air is here. Here 0% sugar present. Still sugar is not going to transport in this air. Why? Because chemical potential. Both sides, there is no difference. So this is the basic thing, or maybe solubility difference. So this is the basic thing that directly related or indirectly related with that chemical potential. So only concentration difference can't do mass transfer operation, but concentration difference every time is going to do molecular diffusion for you. Okay, now here just classified like gas case you will see in diffusion, gas liquid that is absorption mass transfer phenomena, stripper distillation mass transfer phenomena, gas solid you will see one chapter drying, liquid extraction or diffusion also is there, liquid case, liquid solid in which you will see crystallization chapter, leaching chapter, and solid not applicable in this mass transfer operation subject. Okay, now one basic thing here I want to show you, bulk flow transport versus diffusive transport. A few small topics are there, कुछ छोटे छोटे topics हैं उसको बस देख लो. When you are going to take air from outside, then this transport is what? This is your bulk flow transport. Bulk flow transport, ये कैसा ट्रांसपोर्ट है बेटा? दिस इज bulk flow transport. And now when hemoglobin of your blood is going to take oxygen from this air, what is this? This is diffusive transport. This is diffusive transport. And in many interviews already asked this question. So bulk flow transport, that is due to pressure gradient. Diffusive transport, that is due to concentration gradient. General example where both happens, human breathing. Okay, now few important points to remember about diffusion. So just I am going to read one by one and if any doubt you can ask me. Okay, so फटाफट यहाँ देखेंगे, सभी लोग ध्यान देंगे बेटा. सर प्लीज केमिकल पोटेंशियल को क्लियर कर दो बेटा. प्रदीप, हियर आई कांट explain chemical potential because this is a crash course and chemical potential I will explain in thermodynamic subject बेटा. ओके प्रदीप, वहाँ थर्मोडायनेमिक में आपको हम केमिकल पोटेंशियल को एक्सप्लेन कर देंगे. अदरवाइज इफ आई एम गोइंग टू एक्सप्लेन अदर सब्जेक्ट टॉपिक ऑल्सो देन इट विल बी वेरी वेरी एक्स्ट्रा टाइम आई हैव टू गिव. बट उस केस में ये लंबा खिंच जाएगा सब्जेक्ट, फिर बच्चा सोचेगा इतना ज़्यादा घंटा हो गया. दैट्स वाई फॉर दैट डोंट वरी, आई विल टेक थर्मोडायनेमिक in lecture number 1 itself of chemical equilibria. You will see that chemical potential details. Okay, and if you want to see in the detailed manner my solution thermodynamics lecture already in Gate Chemic Learning App, you can see from there. Okay, so here I have to focus on mass transfer operation because in complete journey of mass transfer operation in all numericals there is no need to use any concept of chemical potential. That is topic of thermodynamics. उसके बारे में डिटेल कहाँ देखोगे? In thermodynamics. Now see, few points you have to remember. Point number 1, what is diffusion? क्या है diffusion? हायर कंसंट्रेशन से लोअर कंसंट्रेशन की तरफ में जो मूवमेंट होता है सब्सटेंस का, वही है डिफ्यूजन. इट इज द मूवमेंट ऑफ अ सब्सटेंस फ्रॉम हायर कंसंट्रेशन टू एन एरिया ऑफ लोअर कंसंट्रेशन, दैट इज डिफ्यूजन. कहाँ होता है डिफ्यूजन? लिक्विड में भी हो सकता है, गैसेस में भी हो सकता है, क्योंकि उसके पार्टिकल्स रैंडमली प्लेस टू प्लेस मूव कर सकते हैं. इट कैन हैपेंस इन लिक्विड and gases. Why? Because their particles can move randomly from place to place. Third one, it can also take place by difference of temperature, as I already told you, thermal diffusion. I told you na, thermal diffusion, or due to pressure difference, pressure diffusion, due to some force, AD diffusion. But only due to concentration difference you are going to consider here in chemical engineering, that is your molecular diffusion. I hope till now all points are clear. Now, if you want to see some non-chemical driving forces, as I told you that case, solubility is also the reason. So solubility is going to change. Suppose this is H2O. How much sugar you can dissolve here? If I'm asking at 30 degrees Celsius, at 60 degrees Celsius, in same quantity of water, can you tell me? In both cases you are going to dissolve, you are able to dissolve same amount of sugar or in any case more amount? Just tell me in comment section बेटा, क्या दोनों में सेम अमाउंट ऑफ शुगर डिसॉल्व करेगा या किसी में आपका ज्यादा भी डिसॉल्व करेगा? आराम से सोच के बताएंगे सभी लोग, एवरीवन. 30 60 in both same or different, or if different then in which case more? Yeah, 30 is more. No beta Rakesh, if temperature you are going to increase, solubility is going to increase. For normal substances. Okay, some reverse salt is also there, but that is exceptional case. Sugar not having any reverse solubility beta. If you are going to increase temperature, solubility is going to increase. Solubility is going to increase. Okay, so maybe some other driving forces are also there, like here you are seeing temperature. So there are some non-chemical driving forces too, by which mass transfer takes place. Example, solubility of sugar depends upon temperature of solvent. Okay, 60, very good, better Rakesh. Now, molecular diffusion, as I already told you, is a very slow process. You know, one beautiful experiment had done, nearly 30 years had taken in order to get nearly uniform solution यार, इतना slow है ये. But it is not too much slow in all cases. सारे cases में इतना slow नहीं कि 30 साल लग जाएगा. But molecular diffusion is a very slow process यार. Whereas AD diffusion is a very fast process. So molecular diffusion is the pillar of chemical engineering because this is a slower one. And here we are going to deal this one in detail manner. जो स्लो करता है आपके काम को, उसी को तो पढ़ोगे कि उसको तेज कैसे कर सकते हैं. जो पहले से बहुत तेज है उसको देखने की क्या जरूरत है. जैसे आप सीआरई में पढ़ते हो तो रेट कंट्रोलिंग स्टेप कौन सा होता है, वही होता है ना जो स्लोवेस्ट होता है. If you are going to see in CRE subject, you are going to consider which one is your rate controlling step, slowest one na, not fastest one. So every time you are going to give more and more attention to the slower or slowest step in your overall process. That's why we are going to deal in detailed manner which one, molecular diffusion, not eddy diffusion. Eddy diffusion कुछ पढ़ना ही नहीं है. Why? Very fast phenomena यार. जब इतना फास्ट होता है तो उस पर कोई रिसर्च की जरूरत ही नहीं है, फटाक से हमारा काम हो गया. So that's why we are interested here to deal molecular diffusion in detail manner. Now, in our complete syllabus, everywhere I will tell just diffusion. That means we are dealing molecular diffusion. With the help of a statement, you can also understand that this is the case of molecular diffusion. Okay, because as I told you in numericals, they are not going to vary temperature or total pressure. ठीक है. So बेटा एक बार सभी लोग बताएंगे. Everyone please tell me. All things are crystal clear, beta. Can we proceed? Can we proceed, my dear students? Come on, everyone, tell me, beta. Can we proceed? No doubts at all. All things very easy. चलो बहुत अच्छा. Now, few quantities you must know if you want to feel molecular diffusion यार. First one is mean free path. पहला आपका mean free path है. Now, what is mean free path? I will tell you. Don't worry. ये तो 1 के बाद 2 आएगा ना रे बाबा. एक मिनट रुक जाओ. ये नंबरिंग को थोड़ा मैं सही कर लूँ. जस्ट वेट बेटा. It's 2, it's 3, it's 4, it's 5, 6 and 7. Now, mean free path, molar concentration or mass concentration or mole fraction, mass fraction, velocity, what is mass average velocity, molar average velocity, concentration difference, concentration gradient, mole transfer rate, molar flux. ये सारा आपको देखना पड़ेगा. These all you have to see. What is this? So I'm going to start with mean free path. Mean free path. What is mean free path? Just try to understand. Suppose this is some vessel. ये कोई vessel है. This is some vessel in which some liquid you are going to fill here. Maybe it is water. Maybe it is water. Suppose water. Suppose it is water. Suppose it is water. And like ink, suppose some particle is here. Some other particle is here. And it is going to move here. After traveling some distance, here it is going to collide with some other particle and going to change its direction. And now again travel. So it is going to travel in this zigzag manner. Now, once, suppose this is a vapor. So once it is perpendicular to the surface, now it is able to cross this surface easily. Suppose I want to check what is the value of mean free path before escaping. What is the mean free path? So the path that it is going to travel without any collision, that is its free path. The path, what is free path? What is free path, beta? What is free path? Without collision. without collision, without collision. And in every example, free path is going to differ every time, every time. Like the first may be of a 0.2 mm, then the second one it may be 0.3 mm. Just I'm giving a typical example. Okay, suppose from here this point to this point, it total path it is going to travel, total path traveled, total path traveled, suppose 70 meter. Okay, and in order to travel this total path, suppose it is going to take number of collisions. Suppose I am giving some number like 2000, like 2000. So my dear student, this is known as mean free path, mean free path. मतलब ऑन एन एवरेज हर एक बार कोलिजन के पहले वह कितना डिस्टेंस ट्रेवल किया, ऑन एन एवरेज हाउ मच डिस्टेंस इट इज गोइंग टू ट्रेवल बिफोर every collision. That is your mean free path, that is your mean free path. I hope everyone able to understand what is mean free path. Like in this example you can see 200, 7 by 200, 7 by 200. So I think it's 0.035 मीटर. एक बार चेक कर लेना है कैलकुलेशन. ओके, इज इट क्रिस्टल क्लियर टू ऑल ऑफ यू बेटा? इज इट क्रिस्टल क्लियर माय डियर स्टूडेंट्स? टेल मी एवरीवन, इज इट क्रिस्टल क्लियर? We write or wait for green slide. But Rakesh, here every time you have to write along with me, because in mass transfer operation, I am not going to show that my detailed lecture slides here, because by that slide you will be confused. Okay, if I'm going to deal that in faster manner, because that's why here I'm going to write every topic and लिख लिख के आपको पढ़ाना पड़ेगा. Okay, so with me you have to prepare your notes, because I will give here slides only like green slides. Okay, यहाँ green slides के रूप में ही आपको slides लगातार बनवाते जाने हैं, because this is a very very big subject, this is a very very big subject. Okay, overall I had taken in detailed manner approximately I took 80 lecture, 80 lecture, and here I am going to finish this in just 8 to 10 lecture or 11 lecture. But again I am promising you that I am not going to leave any topic. Okay, so based upon my experience I am going to give you, and definitely you will see approximately 100% question is going to asked from my this crash course. It is open challenge, rank 1 marks. You can compare, you will be able to score more than that rank 1 marks just by my crash course. Okay, is it crystal clear to all of you beta? If not, come lifetime I am going to leave this industry, or you can say this gate. कभी गेट को पढ़ाएंगे ही नहीं, ठीक है, अगर ऐसा नहीं हुआ तो. So it's my promise, open challenge. Okay, is it crystal clear to all of you? Yeah, but I will share slides after the lecture. Okay, but slides PDF is only and only available for paid members, because it will be uploaded in Gate Chemic Learning App. बेटा ये Gate Chemic Learning App में upload होगा. Okay, if unable to find on Play Store, you can ask for link on my WhatsApp number or calling number 9451707049. So this is what a mean free path. This is mean free path. Now, what is molar concentration, mass concentration? It is nothing, yaar. Molar concentration is molar density. Mass concentration is mass density. And you know what is mole fraction? What is mole fraction? Like XA. So, what is total moles of A upon total moles of that mixture? NT and total. And if you are going to see mass fraction of component A anywhere, my dear students, then what is the mass of A upon total mass of that mixture or that solution? So very very easy things here, very very easy things here. Okay, molar concentration, basically here we will use some C, capital C, in order to denote this in our mass transfer operation subject. And this is nothing, this is what, this is mole per unit volume. That means you can write N by V. What is this mass concentration, beta? Very easy. It's mass per unit volume. Okay, but mostly you will see that in this subject we will deal in this molar unit. हम molar unit में mostly चीजों को deal करने वाले हैं. Okay, so I hope these two terms are crystal clear to all of you बेटा. सभी बच्चा लोग को clear होना चाहिए. Next is velocity, mass average and molar average. This is also very easy, very easy. The formula that you are going to use here, जो formula पे यहाँ use करोगे, similar to average molecular weight that you had seen in process calculation. What is the formula? MW, molecular weight average, summation of XI MI, where Mi is the molecular weight of ith component, molecular weight of ith component. And what is this xi? Can you tell me what a mole fraction, mass fraction, or anyone can be there in case of that average molecular weight? बता सकते हो क्या? पता है आपको? You know? पता है तो बताओ जरा यार. Tell me everyone if you know. Don't know then please write R in comment section यार. If you don't know then you can write R in comment section. क्या बात है भाई? Mole fraction. Absolutely correct बेटा. This is mole fraction of ith component. ये ith component का क्या है बेटा? Mole fraction है. So here when you are going to write beta V, mass average, then this is what? Summation of I equals to 1 to n. Same here also you can write for n number of components in a mixture. Now xi dash mi. What is this xi dash? This is mass fraction. Oh sorry, not mi, vi na. This is mass fraction and this is their individual velocity. Okay, what is V? Molar average. Very easy, summation of I equals to 1 to n, then here xi into vi. And you can also convert this in some equivalent form in terms of density, concentration. Like you know, concentration of a component upon total concentration is also a mole fraction. So you can also write in terms of concentration or density or molar density. But this is the most important formula because only by using this formula you are able to solve numericals easily. Yeah. You are able to solve numericals easily. And because this is crash come full course, so I am giving you here the main formula. Okay. And if required, you can convert it. Now, see beautiful numerical based upon this. A gas mixture containing 10% hydrogen, 25% CO2, 20% oxygen, 45% nitrogen by volume. You know, whenever you are going to see gases, even if not mentioned in your problem, अगर आपके problem में mention नहीं है. But one more thing, not mentioned and also not given any non-ideality data like compressibility factor etc. अगर आपको mention भी नहीं किया है कि ये ideal gas है कि नहीं और non-ideality का कुछ data भी mention नहीं किया है, then you can assume even in gate examination that the given gaseous mixture or gas is an ideal gas or ideal gas mixture. Okay, so because not mentioned here every anywhere like this is ideal gas, so and also no non ideality data is there, नहीं दिया है non ideality data यहाँ पे और mention भी नहीं किया है, so I am assuming ideal gas. And for ideal gas we know mole percent is equals to volume percent is equal to pressure percent. That means this we can use like mole percent. So mole fraction of hydrogen 0.1, mole fraction of CO2 0.25, mole fraction of O2 0.2, mole fraction of nitrogen 0.45. I hope everyone able to understand. So just I extract these data here. See, ये हमने data extract कर लिया. Okay. Now we have to calculate mass average and molar average velocity of the given mixture in meter per second, and all data is also given in meter per second. So no need to worry about this. Okay. Now, what is mole average? This was the formula. Just open for four components. So X S2, VS2, XCO2, CO2, XO2, VO2, XN2, VN2. Now, velocity is also given. See, flows through a tube of 5 centimeter diameter at 9 bar total pressure. No need to use these data. If velocity of respective components are, respective means the first one is for hydrogen, second one is for carbon dioxide, थर्ड वन इज फॉर ऑक्सीजन, फोर्थ वन इज फॉर नाइट्रोजन. सो आप यहाँ देख सकते हो बेटा, 0.05 हियर, 0.005 here, 0.02, 0.01. Now just I'm going to put here and one line numerical. See, we got answer. I hope everyone crystal clear in this numerical. बेटा बोलो सभी को clear है? Can we proceed my dear students? Can we proceed? Done. Just बेटा para boy, just extract data and put there बेटा, just extract data and put there in their formula, उसके formula में put कर देने का, and nothing special. Now second one, we have to calculate, we had calculated this one, this mole average, because we used mole fraction. अब mass fraction use करना पड़ेगा ना जी mass average के लिए, so we have to convert mole into mass. And the short trick I'm going to discuss with you guys here. See, solve with the help of short trick. What is this short trick? Wait. Just I am adding one slide here for some more discussion of that short trick. Actually, this short trick you will also see in my process calculation subject beta. Okay. Suppose beta, two components are there, component A and component B. Okay. And if X-A and X-B is written as their mole fraction, and X-A dash and X-B dash is given as their mass fraction. ये mole fraction है बेटा, और ये क्या है? Mass fraction और mole fraction. Now, if suppose this data is given and you want this data, then what is the short trick beta? You know composition is not going to vary with the total amount. Like if you are going to take 1 glass sugar solution from a big drum, then if the uniform solution is there in that drum, the drum composition still remains same, and the glass in which that sugar solution you had taken, also it is going to same composition of that drum. अरे ड्रम में से एक शुगर के सॉल्यूशन को निकालोगे तो ड्रम का कंपोजिशन थोड़ा ना बदल जाएगा, अंदर जो शुगर सॉल्यूशन है उसका, या गिलास में जो शुगर सॉल्यूशन निकालो उसका कंपोजिशन थोड़ा ना बदल जाएगा यार. सो व्हाट आई वांट टू टेल यू, मोल फ्रैक्शन और मास फ्रैक्शन इज नॉट गोइंग टू डिपेंड अपॉन टोटल क्वांटिटी. ओके, अगर उसी टोटल क्वांटिटी को हम कम लें या ज्यादा लें, इट इज नॉट गोइंग टू वेरी. सो हियर एवरी टाइम आई एम गोइंग टू टेक बेसिस एज वन, टोटल 1 kg or 1 kilomole. So here I want to convert this to this now, this to this. So XA dash, this is mass. So XA, if I'm using here my basis as 1 kilomole, suppose in actual quotient it may be 100 kilomole, 80 kilomole, 70 kilomole, no need to worry, no need to see that basis. Just took your basis 1 kilomole, because you are not solving complete problem, you are just obtaining mole fraction or mass fraction. So clearly the XA will also give you amount, like suppose XA is given 0.4, XB given 0.6. So if you are taking 1 kilomole, automatically 0.4 kilomole XA and 0.6 kilomole B. So in order to convert mole into mass, you have to multiply with molecular weight. If you want to convert mass into mole, then you have to divide with molecular weight. Here what is the question beta? You want this mole into mass, so clearly you have to multiply with molecular weight, just A. And on bottom same thing you have to do for all components. So this is short trick. If you don't know, then please install this in your mind. Now suppose reciprocal you want to do, you want to obtain X. This time suppose this is given and this is not given, what to do यार? अभी क्या करोगे यार? अभी क्या करो? No need to worry. XA dash is given, this is mass, so convert into mole by dividing. and in denominator you have to do the same thing beta. So this is short trick. If you don't know, then please install this in your mind beta. So same thing here also I had done. See XS2, so XS2 MS2, I had converted all mole fraction into respective mass fraction. See, and once I had converted this, again just you have to fit in this formula, you will get your answer. Again you have to solve these numericals so that you will able to understand that you are able to obtain right answer with the help of your कैलसी और नॉट, क्योंकि कैलसी से भी बहुत मिस्टेक होती है। तो ये सारे जितने प्रॉब्लम यहाँ हम लाइव में कराते हैं और सॉल्यूशन यहाँ हम पहले से इसलिए दे दिए हैं जिससे हम लोग कम समय में ज़्यादा क्वेश्चंस लगा सके। ठीक है, सो ये आपको वापस से रिप्रैक्टिस करना होता है। ओके, जस्ट इफ यू वांट टू मोर कॉन्फिडेंस, और इस तरह से आप कैलसी से सही आंसर लाना सीख जाओगे। नाउ next is concentration difference beta. Everyone tell me beta, till now all things are crystal clear. Can we proceed my dear students? Just confirm me everyone. Can we proceed beta? यहाँ तक किसी को कोई डाउट नहीं है ना? Everyone crystal clear? Just write CC in comment section beta everyone. कोई डाउट है then please ask me. Can we proceed? I'm not able to see your comments beta. Wait, let me refresh. Okay, crystal clear. Fantastic. Concentration difference, very easy thing. Like suppose at this point beta concentration is Ca1 and at this point concentration is Ca2. So what is the concentration difference between these two points? It's delta Ca, and it is, suppose transfer is going in this direction, so this is Ca1 minus Ca2. This is your concentration difference. What is concentration gradient? Suppose the same example you are taking, at this point concentration is Ca1 and at this point concentration is Ca2, and these 2 points are available at some distance z. So my dear students, concentration gradient, that is dCA by dz, you can write here beta, and this is what? Ca1 minus Ca2 upon z. That means just you are going to divide with this z. Okay, again the mass transfer, suppose I am writing in this direction. Okay, so 0 to z. What is mole transfer rate my dear students? Very easy, very easy. That means at any plane, if you are going to check at which rate any respective component is going to cross this, कोई भी component इसको किस rate से cross कर रहा है. So suppose for component A, so it is Na, so you are writing in unit mole per second, mole transfer rate. You can also write mass transfer rate, then kilogram per second, if you want to write mass transfer rate. And in some places they can also write mass transfer rate given mole per second. So sometimes in this subject also used as synonym, so please don't confuse, beta, confuse मत होना. अरे यार सभी कुछ मिटा दिया हमने तो, वेट कोई बात नहीं. Ca1 Ca2, so concentration difference was Ca1 minus Ca2, that is delta Ca, and if these 2 points at some distance z, then concentration gradient is dCA by dz, or you can write my dear students Ca1 minus Ca2 by z, whereas the transfer is going in this direction, higher to lower concentration, higher to lower concentration. High concentration to low concentration. What is mole transfer rate my dear students? Very easy, very easy. If you are taking some plane, as I told you, then at what rate any respective component is going to cross this. Like if I am writing Na, so what is the value of Na my dear student? It is in mole per second. Okay, it is in mole per second. And maybe in your examination they can ask you, no, 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 please tell me what is mass transfer rate in kilogram percent. No need to worry. No need to worry. You can also write mass transfer rate in similar manner here. So MA equals this time in kilogram per second. One dot may also be there. Depends upon what unit you are going to use. Now, one very important thing that I want to discuss here on this slide, beta. See what? See what? In fluid mechanics, you know, mass transfer can also be given as rho UA. Rho UA. What is rho? What is U? What is it? A is area, so clearly unit meter square. U is velocity, it's meter per second. Rho is mass density, so kilogram per meter cube. Now you can solve this. Meter cube cancelled. What is coming? Kilogram per second. So in similar manner, you can also write in place of this Na. But now this is going to replaced by rho m, or this rho m here in mass transfer operation you can define, you can represent by C. So Cu. हम मोल ट्रांसफर रेट को ऐसे भी लिख सकते हैं. व्हाट इज द यूनिट ऑफ सी? किलो मोल और मोल पर मीटर क्यूब. व्हाट इज यू? मीटर पर सेकेंड. एरिया मीटर स्क्वायर. मीटर क्यूब कैंसिल. सी इट्स किलो मोल पर सेकेंड. टेल मी बेटा, एवरीवन एबल टू अंडरस्टैंड? ये सभी को क्लियर है? कैन वी प्रोसीड बेटा? नो डाउट्स? All clear? Okay. Okay, beta. So see. Next is molar flux. What is the meaning of molar flux? Just like you had seen, heat transfer rate, heat flux. So what is the rate of transfer from some unit area? That is now here. Same thing you are going to check. But now NA by A. Okay. Is it okay, beta? So it's kilo mole per meter square per second. This is what? This is your flux, beta. And maybe if you are taking in mass unit, then kilogram per meter square per second. Okay, is it clear? अब बेटा सारे सब्जेक्ट्स यूट्यूब पे नहीं आएंगे बेटा, क्रैश कम फुल कोर्स पे. इफ यू वांट टू सी ऑल सब्जेक्ट्स देन यू हैव टू ज्वाइन पेड कोर्सेज. थोड़ा पेड कोर्सेज भी लगाना पड़ता है ना, बिकॉज हियर नो वन इज गोइंग टू फाइनेंस फॉर अस. कोई हमारे लिए फाइनेंस नहीं कर रहा, तो जो भी चीज़ें ऐप चार्जेस और बहुत सारे चार्जेस होते हैं वो चलेगा कैसे, और हमारा खर्चा चलेगा कैसे? आर एबल टू अंडरस्टैंड बेटा? सो ऑल सब्जेक्ट्स आर नॉट फ्री. इफ यू वांट टू ज्वाइन ऑल सब्जेक्ट्स you can just WhatsApp or call on 9451707049. Huge offer is going on. Very less prices there. Okay, now see some fundamental equation of diffusion. Try to understand. समझने की कोशिश करना बेटा. In my previous example, just I move phase. Distance some observer is there. उस समय कुछ नदी का पानी चल रहा था. अभी पानी की बात नहीं हो रही, अभी नदी के सामने कोई इंसान खड़ा होकर ऐसे देख रहा है, अभी उसकी बात हो रही है. और अभी नदी चल रहा था ना, अब नदी के साथ साथ इंसान दौड़ रहा है, इंसान भी चल रहा है. जैसे नदी के अंदर मछली चल रही है, सपोज नदी का पानी स्टेशनरी है, मछली चल रही है, तो आदमी भी साथ साथ में चलते हुए उस मछली को देख रहा है. अगर मछली 2 मीटर पर सेकंड की रफ्तार से चल रही है, आदमी भी 2 मीटर पर सेकंड की रफ्तार से चल रहा है, तो बता सकते हो आदमी को क्या फील होगा, मछली की रफ्तार क्या है. इफ द फिश इज गोइंग टू ट्रेवल इनसाइड एन स्टेशनरी river at some velocity of 2 meter per second, and some observer that is watching from outside is also running in the same direction and the same speed 2 meter per second, can you tell me what is the speed that the observer is going to feel there? Can you tell me in comment section, everyone? Just confirm me beta. Can you tell me? Yeah, it's 0. So that thing I am going to discuss here in these three A B C. So relative velocity of spaces, in the three frames of reference. Okay, so first one, observer is stationary. So fish is traveling at some. Now here I am not talking about phase is also drifting. No, this time river is stationary. In all cases, river is stationary. Observer is moving or observer is stationary. What he is going to absorb there, that I am going to discuss. Okay, and just is present in all standard books, so very very important, so that maybe they are going to just ask this equation, which one of the following is correct. आपसे इतना भी पूछ सकता है, तो ध्यान रखना इस बात को. Okay, so clearly if the man is stationary, he is not moving, its velocity is zero, and fish or any component that is diffusing in that phase is moving at some velocity of ua. Observer will feel what velocity? It's ua na, 2 2. But when this is 2, this is 2, so 2 minus 2, it's 0. But if the fish traveling at 4 and man traveling at 2, what is his speed? 2. Observer will feel 2. Okay, so this is the case. The observer is moving with the mass average velocity. This time observer velocity is given in terms of mass average velocity. So you are using here also mass average. Here moving with molar average velocity. So you are writing in terms of molar. So these two are just change. Just you had seen a change is there. Just a change is there, that you are taking molar average or mass average. Okay, so everyone able to understand when 4 minus 2, when just 4 or just, please tell me everyone, ये सभी को clear है? Clear sir, चलो बहुत अच्छा. So relative to a stationary observer, so Na by A, as I told you, this is mass flow rate. So Na by A, n equals to rho ua. See rho ua, I told you na rho ua. सी ना, सी यहाँ देखो ना, अभी तो बताया ना रो यू है, ये तो है ना रो यू. सी दिस इज रो यू, दिस इज रो यू. तो सेम फॉर्मूला अगेन आई एम यूजिंग, सो नथिंग स्पेशल हियर ना. क्या कुछ स्पेशल है क्या? ना ना, कुछ स्पेशल नहीं है. सो एन ए बाई ए, रो ए यू ए, एंड रो ए मे बी इट इज नॉट मास डेंसिटी, इट इज मोल. दे मे आस्क इन मोलर यूनिट, सो नो प्रॉब्लम, आई एम यूजिंग सी ए. नाउ जस्ट किलोग्राम रिप्लेस्ड बाई किलो मोल. कितना आसान है ये सब लिखना, देखो ना, हाउ इजी टू राइट. Second one, relative to an absorber moving with the same with the mass average velocity u. So I am representing this time, suppose NOA. So you had written UA minus U in previous page. See UA minus U. So same you are going to use that velocity here, because here you want that diffusion relative to that absorber. उस absorber की relative क्या है, सापेक्ष गति क्या है उसकी. So observer की गति को घटाना पड़ेगा. You want to calculate relative, so you have to subtract observer speed there. Are you able to understand everyone? So same thing here also, same thing here also. Only difference is there, that's at one place molar, at one place mass. So I hope everyone able to write these all things. ये सभी आसानी से लिख सकते हो. एक बार just write CC in comment section if you are able to write these all formulas easily, because only rho ua, if you remember rho ua, then it's okay. And you have to remember when you are going to use just ua or when you are going to use ua minus u. Okay, clear everyone? Please tell me beta, फटाफट बोलते रहा करो, so that we can move forward in little bit faster manner. All clear? चलो. What is the fixed law of diffusion? What is the fixed law of diffusion? So my dear students, according to fixed law, the molar flux is directly proportional to concentration gradient and the proportionally constant DAB you are going to use here, and this DAB is known as diffusivity. This DAB is known as diffusivity. ये DAB क्या है? ये DAB आपका diffusivity होता है. See, DAB is diffusivity here. So just equation you have to remember here. Na by equals to JA DAB dCA by dZ. Sometimes you have to use this minus, sometimes not. When you have to use minus, when not, I will tell you later. Okay, now if you want to define this DAB, that was diffusivity. ये क्या है? Diffusivity, that is diffusion mobility of component A in B. A component B में या A B के मिक्सचर में कितनी आसानी से घुस सकता है, A B में कितनी आसानी से घुस रहा है जहां B है. कितनी सुगमता पूर्वक जा सकता है। मोबिलिटी की मेजरमेंट है, इट इज द मेजरमेंट ऑफ मोबिलिटी ऑफ ए इन बी, that is diffusivity, known as diffusivity and also known as diffusion coefficient. Now if you are going to put a equals to 1 meter square, if you just I am going to define one beautiful definition for it. So a, if I'm putting 1 meter square, and if the concentration gradient at that point is also unity, then clearly you can see n equals to dab now. So we can also define diffusivity can also be defined as the rate of mass transfer. See, defined as the rate of mass transfer from unity area, from unity area when concentration gradient is also unity, when concentration gradient is also unity. Okay, so you have to remember this equation. बेटा ये equation आपको याद करनी पड़ेगी. Okay, you have to remember. It's very easy, very easy equation. Analogous in nature, like you had seen in heat transfer operation. Fourier's law जो आपने देखा था उससे मिलता जुलता आएगा ये. Okay, now what is diffusivity? As I told you, diffusivity is the diffusion mobility of component A in component B. Just like you had seen in heat transfer operation, mobility of heat transfer measured in terms of thermal conductivity. Okay, and analogous nature, one more you had seen there, like thermal diffusivity, K by rho Cp rho alpha. So like the same unit here, diffusivity, meter square per second for thermal diffusivity as well as for diffusivity. It is, oh wait, some, okay, I hope not disturbed. Gradient is a mole, wait, देख लो यार, this is Ca, so it is mole per meter cube dz, so meter, this is the unit. So 1 mole per meter cube per meter. Overall dca by dz overall value is this, like suppose at 2 point the this is 4 and this is 1 and the distance is also 3. So what is the value? 3 by 3, 3 by 3, it's unity, it's unity. Okay बेटा राकेश, आर एबल टू अंडरस्टैंड, समझ में आया? क्लियर? चलो, वेरी गुड. So diffusivity is the diffusion mobility of component A in component B, and clearly if diffusivity is more, the rate of mass transfer or the molar flux value is also more. Okay, what is the unit? Just you can cut and you will obtain meter square per second. Any type of diffusivity, same unit, like thermal diffusivity, mass diffusivity, in fluid mechanics, momentum diffusivity, everywhere unit will remain same, meter square per second. So you have to remember meter square per second, meter square per second. Okay. Now, can you tell me, beta, can we proceed? No doubts? Crystal clear. Okay. Now, few fundamental equations of diffusion you have to learn directly, because here I can't give you derivation. This is crash come full course, so we have to complete in very less time. And also you are not going to derive in examination hall. Derivation is little bit large. So you have to remember this fundamental equation, beta. ये fundamental equation आपको याद करना होगा. Na by A equals to n xa by A minus dab dca by dz. Very easy, very easy equation. Okay, Na by A, use this form to remember, equals to n xa by A. Suppose if two components are there, then n is what? Na is Na plus nb. If binary system, binary means two component, if binary, so n is Na plus nb, n is Na plus nb, you have to put here, minus dab dca by dz. So this is fundamental equation of diffusion, and many equations or many cases you can deal just by using this equation, like equimolar counter current diffusion, B stagnant case, variable area case, many cases are there जो अभी आप आगे पढ़ोगे. वो सारे के सारे केसेस के जो फाइनल इक्वेशन आते हैं आप इससे ही डिराइव करते हो. सो प्लीज एवरीवन रिमेंबर इट, इसे रिमेंबर कर लो, इससे रिमेंबर कर लो, प्लीज एवरीवन रिमेंबर इट, एवरीवन रिमेंबर इट बेटा, इसे रिमेंबर कर लो. यू हैव टू रिमेंबर इट, प्लीज immediately remember it, remember it, because Just this equation can also be asked, and many problems also asked in gate pyq you can find that can be solved in just one line if you know this equation. Okay, I will show you later. Now what is xa? Xa can also be written like ca by c, so both are equivalent equation. What is xa? Xa can also be written as pa by p. Huh? Arey bhai, this is your xa, this is your xa. So xa can be written as partial pressure of a upon total pressure, or it can be written as concentration of a upon total concentration. And you know, if ideal gas is there, so pv equals to nRT, or p equals to n by vrt. N by v is what? N by v क्या है बेटा? मोल पर यूनिट वॉल्यूम है ना. N by v is mole per unit volume, that is concentration. P equals to CRT. So if you are writing for any component case of partial pressure, then just concentration of P equals to CART. So clearly, my dear students, you can also write CA as PA by RT. PA by RT. So you can write DCA as DPA by RT. Why I am not writing D with R or T? Because R and T both are constant here. We are not dealing thermal diffusion, we are dealing molecular diffusion. So just you can convert, you can obtain this one or this one if you are going to remember this one. Tell me, everyone crystal clear beta? ये सभी को क्लियर हो गया? कैन वी प्रोसीड? कैन वी प्रोसीड माय डियर स्टूडेंट्स? फटाफट बता दो सभी लोग. कैन वी प्रोसीड बेटा? कैन वी प्रोसीड? डन. Beta, PA is the partial pressure of component A in that mixture, and capital P is the total pressure. Capital P is the total pressure. Rakesh, capital P is the total pressure. Okay, PA is partial pressure of A. PA is partial pressure of A. See, this is total pressure. This is total pressure of mixture, and this is partial pressure of component A in that mixture. Partial pressure of component A in that mixture. Okay. And in mass transfer operation for gases, mole fraction represented by Ya, and for liquid Xa. So here if you want to write, then you can also write here. If you want to differentiate Xa, Ya, so here you can write what? Ya, and here you can write what? Xa. क्योंकि यहाँ एक ही जब ह्यूमिडिफिकेशन चैप्टर you are going to see Xa, Ya will be used in the same formula. In process calculation, we are not worrying to change their representation. Like every time liquid, gas, every time you can use X. But in mass transfer you can't. In mass transfer option you can't, because it's humidification and drying chapter. You will see in the same formula X and Y both will be present. Okay, चलो आगे बढ़ते हैं फिर हम लोग. Now different cases of Fickian diffusion. Actually two cases of diffusion are there, Fickian and non-Fickian, and in our syllabus in detailed manner you have to study Fickian one. That is followed fixed law. Equimolar countercurrent diffusion, you have to see, very important. B stagnant case diffusion, non-equimolar diffusion, and diffusion through variable area. So now I'm going to discuss these four, and as already it's more than 1 hour, so today I will discuss these two in detailed manner. ये दोनों आज हम लोग detailed manner में discuss कर लेंगे, तभी lecture को end करेंगे along with numericals and PYQs of these two cases. Okay, बोलो. Can we proceed बेटा? यहाँ तक कोई दिक्कत है तो बता दो मैं. If any doubt then please tell me. If no then please tell me. Crystal clear in comment section बेटा. What is BS? BS कहाँ लिख दिया भाई समरीन? BS तो कहीं लिखा ही नहीं है. अरे BS ने सब ये DPA ही है रे भाई. अरे यार, अरे भाई DPA ही है, कॉमन सेंस लगाओ. कहीं DS नहीं है. NA by A, N by A, PA by P, DAB by DZ, DPA by DZ बेटा. ओके समरीन बेटा, क्लियर? बाला, निशांत बेटा, BS तो कहीं लिखा ही नहीं है रे भाई. Crystal clear? Okay, very good, very good. So now first one beta, equimolar counter diffusion. Try to understand with this beautiful diagram, beta. This is the plane where you want to see how diffusion is going to progress. Like this is one bulb, this is another bulb, and now you are going to connect them with a negligible volume capillary tube. This side total pressure is capital P, total pressure is capital P, temperature T, temperature T. Here some valve is present. Why I'm not wearing temperature or pressure, beta? Because we are not dealing pressure diffusion. It is not syllabus. We are not dealing thermal diffusion. We are dealing molecular diffusion. So total pressure must be same both sides. Now suppose here only and only A present, here only and only B present. Okay, and now this is that plane that you are seeing here in this diagram. This. Okay, are you able to understand? सभी को समझ में आ रहा है ना? So just I want to see what is going to happen there. What is going to happen there? So Na by bulk flow or by diffusion, by both. Here it is only and only diffusion, but maybe in some places bulk flow is also there. So by bulk flow and by diffusion, overall Na transfer at which rate? B will also transfer at same rate from this side. Why? Because every time the total pressure must be same. What is pressure actually? What is pressure actually? So pressure is proportional to particle density. That is number of particles in that in some given volume. कितने पार्टिकल्स है किसी गिवन वॉल्यूम में. अगर यहाँ से आपका 10 ए इधर को गया है, सो सेम टाइम में माय डियर स्टूडेंट्स 10 बी उधर से इधर आना ही पड़ेगा. सो इनिशियली if 100 A here, 100 B here, and now after some time if this is 90 A, 10 B, so here also it is 90 B, 10 A, because total pressure must be same. Must be same. Okay, so clearly you can see that's why it is this case is known as equimolar. Equimolar, and the direction of A and B is totally different. So counter current, एक इधर से इधर जा रहा है तो एक इधर से इधर आ रहा है. Equimolar counter current diffusion. What is this beta? This is equimolar counter current diffusion. Total pressure is constant. Total pressure is constant. If you want to write a more, my dear students, then here you can also write temperature is also constant. Temperature is also constant. Temperature भी यहाँ पे क्या है बेटा? Temperature भी constant है. Okay, temperature is also constant. Are you all able to understand beta? Temperature is also constant. Very good, fantastic. So Na equals to Nb. So our minus sign represents that their direction is indifferent. Direction is different. Okay, so rate of B is same in magnitude of A but in opposite direction. थोड़ा फारसी में लिख दिया है, राइटिंग यहाँ अच्छी नहीं है हमारी. Try to understand. That's why I'm reading. Rate of mass transfer of B is the same in magnitude of A but in opposite direction. So whenever you are thinking equimolar counter current diffusion, if two components are there, so you can write in place of Na minus Nb, in place of Nb minus Na. This is equimolar counter current diffusion. Okay. Now by using the same mother equation of diffusion, fundamental equation of diffusion, that was Na by A is equals to Nxa by A minus Dab dC by dz. You can use that equation in order to obtain min equation. So here which equation you are going to get, derivation I'm not going to give here because crash come full course and that derivation is not important for your examination point of view, GATE examination or any type of competitive examination point of view. So the equation that you have to write here beta, very easy. Na by A. If they are asking mass transfer rate, then just write Na. If mass flux or molar flux, then Na by Na. And in some cases they can also write mass transfer rate in unit kilogram per meter square per second. That means they are telling mass transfer rate but they are asking mass flux. So be careful in examination. Unit को देख के जवाब दोगे बेटा. So Na by A equals to very easy formula, my dear students. DAB you have to remember बेटा, because derivation will take time और आप exam में derive नहीं कर सकते हो. You can derive only formulas in examination, that is just 1 or 2 line derivation and that I will give here. So DAB by RTZ, PA1 minus PA2. PA1 minus PA2. This is one. In terms of partial pressure. You can say this is in terms of partial pressure. In terms of partial प्रेशर, ये पार्शियल प्रेशर के फॉर्म में है बेटा. ओके, नाउ यू कैन ऑल्सो राइट द सेम इक्वेशन. यू नो ना, you know, I can write this PA as this PA as CART. If I can write this PA as CART, so CART, CA1RT, CA2RT, RT cancelled. So I can write DAB by Z only, and here it will be now CA1 minus CA2. I hope everyone able to understand how I had written in terms of concentration. अगर डाउट है तो पूछ लो बेटा, लिख के फिर से दिखा देंगे. In terms of concentration, I will also show numericals and PYQs. Very happy coding बेटा, मैं आदि हूँ, बने रहिएगा बेटा पूरे लेक्चर के दौरान. Now, if you want to write in terms of mole fraction, still it is very very easy to write. You know what is PA? What is PA? PA, you know, see here, see this slide, my dear students. कहाँ गया रे भाई? मास फ्रिक्शन, मोल फ्रिक्शन. Where are you? मास फ्रिक्शन, मोल फ्रिक्शन. Yeah, see this slide. Na by n, or you can also write this YXA as PA by P, or if YA, then you can also write, sorry, in mass transformation this is YA. Okay, and XA, so you can write CA by C. Actually CA by C can also be used for gases, but for liquid PA by P is not possible. So for liquid you have to use only CA by C. So clearly here you can say PA1 equals to PYA1. PA1 I can write like PYA1. So the same thing here you have to do here. Same thing here you have to do. यहाँ आप वही काम करोगे यार. So PA1 can be written as what? P into XA1. PA1 is P into XA1. Am I correct? P into XA1. So P into XA2. PP common. So you can write NA by A equals to DAB by RTZ, and one P here, and inside bracket it is XA1, or if you want to write in terms of Y, no need to worry, you can write YA1 minus YA2. If by mistake here you are writing X or Y, then no need to worry. But in drying and humidification chapter, and also in distillation chapter, don't do this mistake. Okay, same thing here, you can also write. So Na by A, what you can write here? This Ca1 can be written as capital C XA1, capital C XA2, CC common, so XA1 minus XA2, C outside. So DAB by Z into C, and inside bracket, my dear students, XA1 minus XA2. I hope everyone is crystal clear. बोलो सभी को clear है बेटा? Everyone crystal clear? Fantastic, mind blowing, super. साथ साथ में नोट्स बनाते रहेंगे बेटा, because here I am only writing like green slides, because subject is very very big. Okay, so you can't see all complete my detailed slides along with derivation. That will be little bit hectic for you, and you will not be able to concentrate there. That's why थोड़ा हम ज़्यादा मेहनत आपके लिए कर रहे हैं. Little bit extra hard work from my side, and I hope I got result of that hard work. Okay, now see, beautiful numerical number 2, 3, 4. Very very good numerical, based upon equimolar counter diffusion. Two large vessels, just try to understand. Again you have to solve these numericals beta as homework. So two large vessels are connected by a tube of 10 centimeter. See, this is the tube of 10 centimeter. That means this will give you the value of Z. No, it's 10 centimeter diameter, sorry, 15 centimeter in length. So the this is its length, 15 centimeter. 10 is actually its diameter that you can use in order to get its cross sectional area, that is area available for diffusion, here. Okay. Vessel 1 contains 80% nitrogen, 20% oxygen, and assuming this as component A, this as component B. Vessel 2 contains just in opposite, 20 and 80, 20 nitrogen, 80 oxygen. Temperature fixed, total pressure is also fixed, not written but just one data is given, temperature is, pressure is. Calculate number 1, steady state flux and the rate of transport of nitrogen from vessel 1 to vessel 2. The same quantities for oxygen. Then the partial pressure of nitrogen and its gradient in the tube 0.05 मीटर from vessel 1. मतलब इस vessel से कुछ distance पर, vessel 1 से 0.05 मीटर distance, what is the value of partial pressure and partial pressure gradient of nitrogen? So this is the problem समझ गए क्या? बोलो. Everyone able to understand? Yeah beta. Adi, today in my detailed lecture, the things that I had covered in nearly 7 or 8 lectures, just you will be able to see in this one lecture, and that will be more than sufficient. I am not going to leave anything. So as I told you, I am using some scientific method, optimum manner, and based upon my experience, अपने experience के आधार पे आपको वो चीज़ें हम इस तरीके से आपके सामने रखेंगे कि टाइम आपका कोई किल नहीं होगा. आई एम नॉट गोइंग टू किल अ सिंगल सेकेंड यार. ओके. डेरिवेशंस जो इंपॉर्टेंट नहीं होंगे एग्जाम के लिए, दैट वी आर गोइंग टू स्किप. कैन वी प्रोसीड माय डियर स्टूडेंट्स? ओके. नाउ दैट्स व्हाई आई टोल्ड यू कि यहाँ हमें कुछ बहुत एक्स्ट्रा मेहनत करनी पड़ी है चीज़ों को किस तरह से आपके सामने रखा जाए जिससे वो सारी चीज़ें बहुत कम समय में ख़त्म हो जाएं. हाँ, बहुत मेहनत करके स्लाइड्स को प्रिपेयर किया कि कैसे सब कुछ कम समय में हो जाए. मोर पावर टू यू सर, यू आर डूइंग गुड वर्क. थैंक यू बेटा. गॉड्स वर्क. Thank you, beta. Okay, now see, just focus here, beta. So, problem is very, very easy. Problem is very, very easy. Now, see, this is your total pressure data already given here. It's 2 atmosphere and PA1, you know why, PYA1. So, total pressure is given, YA1, it's 80%. So, it's 0.8. So, you will get PA1. Now, if you want to convert in kilopascal, you know 1 ATM. 1 ATM is equals to 101.325 kilopascal. 3 to 5 kilopascal. So just you have to multiply with 101.325 kilopascal. Then same PA2, in our same manner you can obtain 2 into zero point 0.2, because PA2, that means the component A concentration in vessel 2. So this is your vessel 2 and component A concentration, how much? It's 20%. So that's why I'm writing 0.2. Total pressure is still remains same. This side also 2 atm. This side also total pressure is 2 atm beta. The temperature is 20 degrees Celsius. Temperature 20 degrees Celsius converted in SI unit by adding 273. And area, this is 10 centimeter. So it's equivalent to 0.1 meter beta. So what is area? This is circular na, cross section is circular one. So very easy, pi r square, or you can write pi by 4d square. So it's pi by 4d square. All data are there. Now this is just a formula based question. The this second one, formula based. See, just in formula, Na by A equals to dAB by RT is at PA1 minus PA2. Just I am putting here beta. And after putting, this is your answer. Where is answer here? इसका आंसर नहीं लिखा क्या? नहीं लिखा तो है. This is your answer. This is your answer. 3.4939 into 10 raised to power minus 6. Or 3.36 into 10 raised to power minus 6. Between these, this is the range I think I had given here. Okay. Now if you want flux, then it's Na by A calculation. Now again I am telling you beta, these all numericals you have to सॉल्व अगेन, बिकॉज यू हैव टू सॉल्व ऑल्सो बाय योर कैलसी, आपको कैलसी की मदद से भी करना पड़ेगा, बिकॉज दिस इज क्रैश कम फुल कोर्स, सो आई कांट गिव यू एक्स्ट्रा टाइम सो दैट यू आर ऑल्सो गोइंग टू कैलकुलेट हियर। ओके, वो कैलकुलेशन वाला टाइम भी यहाँ पे कट किया हमने, ताकि आप ये रिप्रैक्टिस तब भी करोगे अगर हम कैलसी कर दें, और तब भी करोगे तो दो बार टाइम देने का मतलब नहीं है। सो अगेन यू हैव टू ट्राई बाय योर कैलसी एज अ होमवर्क ऑल न्यूमेरिकल, दैट्स व्हाई यूनिक नंबरिंग इज देयर 1 2 3 4 5 6 every numerical you have to solve one more time, that's more than sufficient for rank 1। एज आई टोल्ड यू, इट्स माई प्रॉमिस कि जो भी आपको पढ़ाया जा रहा है अगर रैंक 1 लाने लायक आपको कंटेंट हमने प्रोवाइड नहीं किया, जिंदगी भर के लिए इस गेट इंडस्ट्री में पढ़ाना छोड़ देंगे, केमिकल ब्रांच का एक भी लेक्चर नहीं लेंगे। इट्स माय ओपन चैलेंज टू ऑल ऑफ यू। अभी इस क्लिप को निकाल के अपने पास सेव कर लो, मान लो प्राइवेट हो जाएगा तो मिलेगा नहीं, ठीक है। नाउ सो फ्लक्स ऑफ नाइट्रोजन, इट्स क्लियर। नाउ इफ यू वांट टू check what is the mole transfer rate or mass transfer rate, no need to worry, mole transfer rate just you have to multiply with that area, so the same thing is going to multiply it with area, very easy here, दिस इज योर आंसर। आई होप एवरीवन क्रिस्टल क्लियर है, बोलो सभी को क्लियर है ना, कैन वी प्रोसीड बेटा। सर माय ओवरऑल सीजीपीए इज 6.2, व्हिच रूल द आईआईटी बॉम्बे यूजेस percentage I convert my CPA percentage is less than 60%। am I listening beta, any outside question or career related guidance, just WhatsApp me, I will discuss there beta, here I can't invest extra time for these, ओके बेटा, बिकॉज इन दैट केस लेक्चर फिर बड़ा हो जाएगा, फिर बच्चा सोचेगा जो रिकॉर्डिंग देखेगा अरे बाप रे इतना बड़ा कैसे देखे हैं, सो अननेसेसरी टाइम हियर आई डोंट वांट टू किल, okay, that is for some other direction, you can ask me any query, these types of career related query on WhatsApp, free of cost you can do your counseling, okay। So the first one is, I hope crystal clear to all of you, the steady state flux and the rate of transport of nitrogen from vessel 1 to vessel 2, I hope everyone crystal clear। Now the same thing you have to do for oxygen also, आपको ऑक्सीजन के लिए भी वही करना, अरे भाई तो व्हाट इज द प्रॉब्लम हियर यार, what is the problem here, this is equimolar counter current diffusion, if you know one value Na, automatically second one is minus Enb now, but wait, in examination for mass transfer operation please don't use negative sign when you are going to write answer, negative sign को मत लिखना, if they are asking what is the mass transfer of oxygen here, so please don't write negative sign। So see, first one already calculated, the second one very easily calculated, because Nb by A, the same value here also, Na will be minus Nb, or you can write Nb is minus Na, so Na by A is equals to, or Nb by A is equals to minus Na by A, okay, so same value, but clearly mentioned, never use negative sign in gate examination for this case beta, okay, is it crystal clear, चलो फैंटेस्टिक। नाउ द थर्ड क्वेश्चन इज वेरी इंपॉर्टेंट, ये तीसरा वाला ना बहुत इंपॉर्टेंट है, बिकॉज दिस टाइप ऑफ क्वेश्चंस आर आल्सो प्रेजेंट इन माय टेस्ट सीरीज, गेट केमिक टेस्ट सीरीज, इफ यू वांट टू बाय यू कैन आल्सो व्हाट्सएप देयर, ह्यूज ऑफर इज गोइंग ऑन, 190 plus tests are there, topic wise, full length, mini, no see here, so for this a partial pressure distribution required here, and approximately I had seen 9 out of 10 student had done wrong in my test series for this question, जो हमने तीसरा वाला क्वेश्चन ये चौथा वाला इसमें पूछा, so actually this is not difficult one यार, बहुत आसान है, it is also very easy, the partial pressure of nitrogen, can you tell me beta, I can give you max 1 minute, can you tell me the value partial pressure of nitrogen in the tube 0.05 meter from vessel 1, I can't give you more than 1 minute, 1 मिनट आपको दिया हमने, चलो बताओ, tell me everyone। Rakesh, in our syllabus only 2 components in mass, no beta, multi-component is also there, but in multi-component only few topics you have to see, like a multi-component diffusivity, okay, so वो आपको अभी हम पढ़ाएंगे, don't worry, the things that is present in your syllabus I am not going to leave a single topic, okay, I will handle all topics, सब कुछ handle करेंगे। हमने कहा ना बहुत मेहनत किया है आपके लिए डिजाइन करने में, कि कैसे इतने बड़े सिलेबस को बहुत छोटे से समय में हम ले आके खत्म करें और जल्दीबाजी में भी ना लगें, सारे न्यूमेरिकल्स भी कवर हो जाएं, थ्योरी भी सारी आपके सामने आ जाए ऑप्टिमम मैनर में, जिससे आप रैंक 1 के काबिल बन जाओ। सो बहुत मेहनत की है कोर्स को डिजाइन केवल करने में। आपको दिखेगा भी लेक्चर, इसी लेक्चर में आपको दिख गया जाएगा क्या डिजाइनिंग आपके सर ने की है। सो नाउ प्लीज टेल मी एवरीवन, if unable to solve then please write R in comment section. Partial pressure of nitrogen, just first one please tell. Partial pressure of nitrogen in the tube 0.05 meter from vessel 1. Rakesh, 0.05. Okay, let me wait for other students answer here. कुछ और बच्चा लोग को आंसर दे देने दो, तब हम लोग आगे बढ़ते हैं। And those who wants to join our WhatsApp group, open WhatsApp group, they can also message on the same number 9451707049 and just mention there, sir, add me in free WhatsApp group. You can discuss with the students and also with me in groups. So क्रिकेट फीवर, अरे यार क्रिकेट फीवर इज वेरी वेरी बैड थिंग यार। क्रिकेट को छोड़ दो देखना, सब फिक्सिंग वाला मामला आजकल चल रहा है, ऐसा फील होता है। हमने तो छोड़ दिया, आप भी छोड़ दो, एग्जाम तक तो कुछ बनने तक तो छोड़ ही दो। मैं आती हूँ 0.34। Okay, very good, fantastic, mind blowing, super. Now, so the right answer is, oh my god, it's minus 8 atm per meter. 8 atm per meter. It's very very easy. It's very very easy. कैसे निकाला रे भाई, कैसे निकाला, ये तो बहुत डिफिकल्ट हो गया। The partial pressure of nitrogen, diffusive value is also given at the same temperature and pressure. Partial pressure of nitrogen at 0.05 meter, yeah, 0.05 meter. So can you tell me, whenever you are going to see equimolar counter current diffusion, you know, every time the gradient that you are seeing, that is dpa by dz, the gradient that you are seeing here can be written in this manner. ये इस तरह लिखा जा सकता है कि नहीं लिखा जा सकता है? This is the gradient now. Now my point 2 and point 1, how to show here? How to show here point 1 and point 2? So the partial pressure of nitrogen and its gradient, partial pressure of nitrogen in the tube 0.05 meter from vessel 1. So this point 0.05 meter, that means 5 centimeter. 5 centimeter. Here you want partial gradient, partial pressure, and nitrogen is traveling, net transport of nitrogen you can see in this direction, okay. So clearly this time this you have to assume as 0, and now the remaining distance present is 15. Okay, this is the case in order to get the gradient at this point. So dpa by dz when you are going to write, so for dz it's 15 minus 0, and you have to write the value of partial pressure here and the value of partial pressure here. So this one you know well, ये तो आपको पता है ना क्या है partial pressure, how you know? 20% nitrogen, so 2 atm into 20%, it is going to give you na yaar, it is going to give you 0.4 atm. It's 0.4 atm here. This is pn2, this is pn2, partial pressure of nitrogen in this vessel 2, and this is the starting point. So clearly here also the same thing, here also the partial pressure is same. But the problem with this data, yaar, how to obtain the value of partial pressure of this nitrogen here, यहाँ कैसे निकालेंगे? This is the main problem here. This is the main problem here, how you are going to calculate the partial pressure here, yaar. See here, 0.4, how I write, you all know how write z minus 0, 15 minus 0, or 0.15 minus 0, that is 0.15 meter. This is also clear. ये सारा का सारा आपके लिए क्लियर है, ठीक है, ये सारा का सारा आपके लिए क्लियर है, ये सारा का सारा आपके लिए क्लियर है, ठीक है। सो इसमें से क्या क्या क्लियर है आपका, क्या क्या क्लियर है, ये कैसे आया, हाउ इट कम क्लियर, हाउ डिस कम क्लियर। नाउ कैन यू टेल मी हाउ डिस कम, ये जरा बताओ। मैं आई एम अगेन वेटिंग फॉर योर कमेंट्स बेटा, एक बार फिर आपके कमेंट्स के लिए वेट कर रहे हैं, फटाफट बताओ। एवरीवन प्लीज टेल मी इमीडिएटली, Everyone, please tell me immediately. Okay, tell me everyone. Still waiting for your comments. 0.8 into 2 ATM. Rakesh. Why 0.8 ATM you are taking here? Huh? Rakesh? Can you tell me better? Why you are taking 0.8 ATM? 0.8 ATM किसने आपको बता दिया यहाँ? Because here in this container it is how much? In this container how much? It's 2 into 0.8. It's 1.6 ATM here. This side 1.6 ATM. This is a PN2. This side PN2. So 1.6 minus 0.4. But here I am writing same 1.6. What is this here? Is it possible? Is it correct? Is it correct? This is not 15. Sorry. This is 10 centimeter here. This is 10 centimeter. So tell me beta. This is why because beta here the distribution is linear. यहाँ linear distribution होता है. Everywhere the slope will remain same. Everywhere the slope will remain same. समझ रहे हो? हर जगह पे आपका slope क्या है? Slope will remain same. So even if you are going to calculate by this, you will get the same. You will get the same. You will get the same thing. That is gradient. That is gradient. So minus 8 atm per meter. Okay. Now, if you want to check what is the value of partial pressure at some distance, no need to worry. You know PA can be written as PA1 plus dPA by dz into delta z. Just fundamental formula. If you don't know this formula, so you have to remember beta. यहाँ पे इसको derive नहीं करा सकते. You have to remember directly. So PA1 plus dPA by dz into delta z. Okay, like if this is the tube, if this is the tube, my dear students, if this is the tube and you want to calculate here, you want to calculate here, what is the value here? What is the value here? So this is at some distance 0.05 meter, no? 0.05 meter. So you have to write dP by dz, overall slope, dP by dz that you obtained. So by multiplying this value with that slope, it is going to give you how much difference come up to this distance. And if you are going to add in this PA1, this difference, it is going to give you the value of partial pressure here. Theoretically, I hope समझा सके आपको, समझ गए आप. Are you able to understand this one, beta? Everyone, please tell me, beta. Is it clear to all of you, beta? I told you, beta, this is PA, this is PA1. See, suppose this is some graph and this is some slope, this is some slope. Okay, and I am asking you what is the value here of this at this y-axis. So कैसे बताओगे इसे? What is the value here? So you know this value. Suppose this is something 5, something 5. So 5 plus how much? 5 plus how much? 5 में कितना ऐड कर रहे हैं? So suppose the slope of this line dy by dx is given as suppose 2. So if you are going to multiply dy by dx with this distance, this dx, suppose this is 20. Okay, so this is what? This is dy by dx into delta x. That is going to give you now what is going to increase in this value, delta y value. So you will get here how much? It's a 2 into 20, it's 40 here. It's 40 here. And previously it was 5. So 5 and plus this 40. So here it is 45. So just fundamental used here. Is it clear to all of you, beta? बोलो सभी को clear है? Just fundamental I used here, beta. Just a fundamental. Okay? So I hope everyone able to understand. So by this fundamental, you will be able to get partial pressure at any point. Okay, and approximately out of 20, only one correct answer I got in my test series for this one. And see how easy it is. कितना आसान है ये. Okay, now crystal clear. Okay, so without any delay, see one more beautiful question that is from 1994, and just formula based question. So I'm not going to invest time here in live class. Solution is also there, so you have to practice. See, all data is extracted, Na by a dB by t is at PO1 is PO2, just putting all values here, ask DAB, solved. Just very easy answer. If not able to see here, answer is 3.898 into 10 raised to power minus 5 मीटर स्क्वायर पर सेकेंड. सो आप इसे सॉल्व करना वापस से. दिस इज योर होमवर्क. ओके, नाउ द इंटरेस्टिंग stagnant case. Many confusions are present how things are happening, and in interviews in bark mostly many times asked, can you show me be stagnant case on a paper, how things are happening there. Very easy. See this diagram, ध्यान से देखोगे बेटा इस डायग्राम को. व्हाट इज बी स्टेगनेंट केस? मतलब बी का नेट ट्रांसफर नहीं हो रहा है. In heat transfer operation, when you are going to calculate heat transfer rate, that is actually net rate of heat transfer. Because if this is 20 degrees Celsius, this is 50 degrees Celsius, this is going to give here, this is going to hit here. Oh sir, but we know only heat can travel in the direction of temperature drop. Sir, only this is possible, this is not possible. Huh? No beta, both are going to happen. Is this statement is true or false? Just that I told you, both is possible, both is going to happen here. True or false? Tell me, true or false? That means 20 is also giving heat to 50, 50 is also giving heat to 20. It's true or false? ये true है या false? जल्दी बताओ बेटा. Tell me everyone, please tell me. Tell me my dear students. If don't know, then please write R in comment section, but don't take too much time. False. राकेश false. दिव्यांश false. सभी लोग बताओ यार, सभी लोग बताओ. True or false? False. Everyone false. My dear students, the statement is true. क्या करते हो यार? No, 100% answer false. But a statement is true. See, this is one heater, high 1000 degrees Celsius heater. This is second heater, 500 degrees Celsius. Radiation is not coming from this heater to this heater. Tell me. अब फील करो. कम टेम्परेचर फील नहीं किया तो ज्यादा टेम्परेचर फील करो. ट्राई टू फील एट हायर टेम्परेचर. इफ नॉट एबल टू फील एट लोअर टेम्परेचर. Radiation is not coming from 500 to 1000 direction. Coming now, and 1000 is also giving here. In your whole heat transfer operation, the Q that you are writing, that is every time you are writing Q net beta. All formula that you developed for your law of heat conduction, everywhere that Q is Q net. Are you able to understand beta? वो सारा का सारा Q net था जो आप Q लिखा करते थे. So heat can travel both sides. Suppose from this side it's Q2 to 1, it's Q1 to 2. So net is Q net is Q1 to 2 minus Q2 to 1. ये आप निकालते हो Q net every time. And if you had seen radiation in depth manner, तो आपको वहां मिला भी होगा. ये रेडिएशन में तो साफ 1 2 2 1 ऐसा करके दिखाया भी जाता है यार. कंडक्शन कन्वेक्शन में नहीं दिखाया जाता है. इन कंडक्शन कन्वेक्शन चैप्टर्स डायरेक्टली यू हैव रिटन Q, but In that case, it is written there. Okay? Is it clear to all of you, beta? Is it crystal clear, my dear students? The same thing here also happen, beta. B and B is 0. That means the net transport of NB is 0. NB is still transporting, yaar. NB कौन कह रहा transport नहीं हो रहा है? But net transport of NB is 0. That's why NB is 0 here. Rate of mass transfer of NB is 0. Are you able to understand? Tell me everyone, just write crystal clear. तब इसको हम समझाएं आपको. फटाफट everyone tell me. Is it crystal clear to all of you? हाँ, क्या बात है भाई, मजा आया. सी बेटा, फ्रॉम बल्क A and B both are coming. From bulk A and B both are coming. दोनों ही आ रहा है रे भाई. From bulk both are coming. Both are coming from bulk. Both are coming from bulk. दोनों ही आ रहा है बल्क से यार. हाँ, दोनों ही आ रहा है बल्क से. Both are coming from bulk. Now, diffusion of A, how they can come? By diffusing and also by bulk flow. If some bulk flow is also there, by diffusing and by bulk flow. So, diffusion of A, bulk flow of A, yeah. Because this surface is going to absorb A only. This surface is able to absorb component A only. So A is coming, adsorb. A is coming, adsorb. What is B? It can't absorb B, na? So B is coming from bulk flow only. There is no diffusion because here no B present, it can't absorb B. Bulk flow of B is coming to the surface and diffusing to the bulk. Coming, diffusing, coming, colliding with surface, back by diffusing to the main stream. So the net effect of B is 0 here. This diagram is very important for interview purpose. So since the total mass transfer of B is 0, there must be a bulk flow of the system towards the liquid surface exactly to counterbalance the diffusional flux from the surface. I hope everyone able to understand that what is happening here if A and B both are coming. And if B is not adsorbed, that means some net flow of diffusion also is present outside in order to counterbalance this bulk flow of B. भाई B आ रहा है, adsorb नहीं हो रहा है, चूंकि adsorb नहीं हो रहा है तो there is no diffusion. So only bulk flow is there. और अगर बल्क फ्लो आ रहा है और फिर भी वहां एब्जॉर्ब नहीं, तो बी जा कहां रहा है, मतलब बी फिर सम डिफ्यूजन के द्वारा वापस चला जा रहा है. तो ये कंक्लूजन निकाला गया, ऐसा कंक्लूजन निकाला गया कि ऐसा हो रहा है. सो मस्ट बी, दैट्स व्हाई रिटन मस्ट. ओके, सी आई एम नॉट राइटिंग शुड बी. शुड मतलब हो भी सकता है, नहीं भी. मस्ट, इट मस्ट बी. सो सिंस द टोटल मास ट्रांसफर ऑफ बी इज 0, so if B is coming, so there must be some diffusional flux of B in same magnitude but in opposite direction. This is B stagnant case. Little theory. I hope I am able to deliver this theory in very less time. Okay, इसलिए ऐसा ऐसा एग्जाम्पल आपके लिए लेके आए हैं कि सारी चीजें बहुत कम समय में आपके लिए हम कर सके बेटा. I hope everyone able to understand. Clear? Very good, very good. Now, few equations you have to write for this. So one is Staten law. So see, what is this law or this equation? Very important equation. Very important equation, beta. So this is N A by A. I hope this font is okay, na? N A by A equals to minus DAB DCA by DZ into C by CB, and this is applicable for B stagnant case. Equation already asked in PSU examination. Okay, in this equation, my dear students, one more important thing is there, that is this C by CB ratio. In this equation, this ratio is known as drift factor. Drift factor, this is known as beta drift factor. इसे drift factor के नाम से भी जानते हैं, जिसकी वैल्यू सामान्यतः एक से ज्यादा हो. इसकी वैल्यू कितनी होती है? इसकी वैल्यू एक से ज्यादा होती है. वैल्यू इज मोर देन 1. Okay, because bulk flow, it is comes when bulk flow is there only. What I want to say you beta, uh, see one beautiful example coming to mind. In some fair, मतलब मेला, कोई मेला है, वहां पे आप जा रहे हो, many persons are there, and you are traveling. huh? Now tell me, in this case your speed, when some person also coming from this side, and in this case your speed, if they are not coming towards your side, in which case you can go faster, case 1 or case 2. Same caliber, you are having same caliber, but in both cases, in which case you can reach this destination fast? In which case? Can you tell me beta? Clearly, it is clearly in second case now. So beta, this second case that you are seeing here, this is the B stagnant case. That means the second one is not going to affect you. B stagnant case. And this is the case of equimolar. This is the case of equimolar. That if one is coming from this to that side, then one is also coming from this to that side. दोनों साइड से आपका काम हो रहा है. Okay. Now few more things beta. Few more things. If you want to write NA by A for equimolar case, then it can be written in terms of B stagnant case, Na by A for B stagnant case. But they are not same. They are not same. Equimolar is going to exceed by C by Cb. Then you will get B stagnant case, this multiplication. And as you all know that C by Cb ratio is more than 1. So clearly you can see, my dear students, for the same value of delta Ca, if you are going to write beta, then Na by A, that you are writing for equimolar counter current diffusion. And if you are going to compare with Na by A, that you are going to write for B stagnant case beta. Clearly this is more. But for same delta Ca. I hope everyone is able to understand. Don't forget to write for same concentration difference of delta Ca. Okay, and one more thing, my dear students, here the drift factor that you had seen, the drift factor you had seen, for many cases you can also write it like Na by A for stagnant case, for B stagnant case, upon Na by A for equimolar case. But again, my dear student, this is true. This equation you can use only and only when you are writing for same delta Ca. Okay, for same delta Ca. बोलो बेटा, सभी को क्लियर? Is it crystal clear to all of you beta? Is it crystal clear, my dear students? Done? Directly you have to remember these equations. Okay, थोड़ा remember कर लोगे, थोड़ा अपने आप याद आ जाएगा. Okay, done? Can we proceed? Okay, so next heading, my dear students, very very important, that is equations. Here you have to write few more equations actually. Equations of B stagnant case to solve numericals. ओके, तो ध्यान से देखेंगे, कुछ इक्वेशंस हैं, इंपॉर्टेंट है उनके फॉर्म. And for this you have to use the same equation, Na by A equals to Nxa by A minus Dab Dca by Dz. In that you have to put N equals to Na plus Nb, and then Nb put 0. That means in place of N you have to put Na. Then after derivation you will get इक्वेशन. अरे यार ये क्या सारा डिलीट कर दिया हमने. चलो कोई बात नहीं, अभी लिख देते हैं इंपॉर्टेंट इक्वेशंस. इंपॉर्टेंट इक्वेशंस फॉर बी स्टेगनेंट. For B stagnant case. Now, see, very easy equations are there. So, number one, my dear students, Na by A equals to DAB by RTZ into P by PBLM. This is also known as, in many places you can see P by PBLM is also known as drift factor. It is also known as drift factor. Okay, that is going to increase the value, drift factor. So into PA1 minus PA2. You can see the same equation also in case of equimolar countercurrent diffusion. Extra term is there, that is P by PBLM. P by PBLM यहाँ पे extra आ गया बेटा. And how to calculate this PBLM? Very very easy. You have to write partial pressure of component B in vessel 2 in vessel 1 upon logarithmic of partial pressure in vessel 2 upon in vessel 1. I hope everyone crystal clear here. Okay, clear beta? Beta, directly formula sheet if I'm going to provide you, you will not be able to understand. So just prepare formula sheet along with me. हमारे साथ साथ आप लिखते चलेंगे. ओके, अदरवाइज वो बेनिफिशियल नहीं होगा, रटना पड़ेगा. ऐसे देखोगे तो बहुत सारी चीज़ें ऑटोमेटिकली याद हो जाएंगी. नो नीड टू रिमेंबर इट. जस्ट वेट, आई वांट टू सेव स्लाइड सो दैट अगेन फिर से हम डिलीट ना कर दें यार. सेव, जस्ट वेट. I think lecture already exceed 2 hours, so we can't take one more lecture today because still I think 20 minute minimum I have to invest here for numericals of this topic. Now, second one, same to same equation you can also write Na by A equals to DAB by RTZ. Just one more form. See, just you know now what you can write in place of PA1. PA1 can be written as PXA1 or PYA1, PYA1, and PA2 we can write P into YA2. लिख सकते हैं ना यार, बोलो लिख सकते हैं. So just by putting these two, you can write above equation as here P common, then it will be now P square. So it is P square and divided by PBLM into YA1 minus YA2. Clear? Is it clear to all of you beta? सभी को clear? Now see equation number 3. Na by A equals to DAB by Z, and here you can also write C by CBLM. C by CBLM into CA1 minus CA2. Oh sir, what are you doing, sir? What are you doing? You know one more equation is there. If you want to write CBLM, then CBLM is nothing but it can be written as XBLM into C. Okay, आप इसे ऐसे भी लिख सकते हो. So here just what I had done, this PBLM, this P, just substituted P by RT, written P equals to CRT. So PCRT, RT cancelled here only and only C present. And now just converting this in terms of CBLM. So one C will also come from that PBLM side when you are going to convert that PBLM. So just by doing that conversion, you will get this one. Okay, one more equation. How extra C here, sir? ये extra C ये bottom में PA1 by RT इसका कहाँ गया? No need to worry. See, This is C1 by RT, CA2 by RT. So PBLM RT, here this is CBLM, nothing special. Now, fourth one, you can use this equation that just written by me, XBLM into C. So here you will write just the XBLM. And also I want to write here XBLM. So what we have to do? NA by A equals to DAB by Z and C. CBLM is C into XBLM. CC cancelled. So only XBLM will be here. But at the same time, CA1 will be written. CA1 will be written as C into XA1. So again, one C XA1, C XA2, so C come outside, one C again come. One cut, but one again come. So XA1, these are just, you can say, synonym equations, same equations. सेम टू सेम इक्वेशन यहाँ पे है बेटा, बट अलग अलग रूप है. द मोस्ट इंपॉर्टेंट इक्वेशन दैट यू कैन यूज इन योर एग्जामिनेशन इज इक्वेशन नंबर 1. But other forms I am giving you because sometimes they can also ask just which one of the following is the correct equation for B stagnant case. So in that case you are able to convert in examination. Okay, सभी को क्लियर है? एक और लिख लो यार, फिफ्थ वन. One more equation you can obtain here, Na by A equals to, see, DAB by Z here, DAB by Z and C by CBLM. If this is the case of gas, what to do? No need to worry, the same thing will be there, but X will be represented by Y. So just same equation, but I am writing this time. I am writing this time for gas. Only that is applicable to gas. So here that I can write DAB by Z into C by YBLM, Ya1 minus Ya2. In terms of partial pressure, in terms of mole fraction, everywhere I hope you are able to write. Now one more thing, maybe in your examination they are not going to provide you enough data, but they are writing for dilute condition, for dilute condition, for dilute condition. For dilute conditions means what? That XA is going to tends to 0. For that type of cases beta, P by PBLM value is nearly 1. And for this case, you can write Na by A for equimolar is nearly equal to Na by A of P stagnant case. So if some data is missing for component B, they are writing just A, and no data is present for by which you can calculate PBLM, no need to worry, just use this approximation there. But if all data are given there, then please use approximation even for dilute if they are giving, because in that case maybe in GATE examination you will not be in the range. अपने साइड से अप्रॉक्स तभी करोगे when data is not given. Okay, clear? What is the formula for XBLM? Same thing beta, same thing. If you want to write XBLM, so what is the value of mole fraction of B in second vessel, mole fraction of B in first vessel upon ln of mole fraction of B in second vessel, mole fraction of B in first vessel. Same thing. This is logarithmic mean beta. Everywhere logarithmic mean. CBLM, PBLM, all things you have to calculate in similar manner beta Rakesh. बोलो सभी को क्लियर है क्या? Is it crystal clear my dear students? Is it crystal clear to all of you beta? चलो बहुत अच्छी बात है. Now see few beautiful numericals here beta. This is problem number 6. Very beautiful problem. Ammonia gas is diffusing at a constant rate through a stagnant air. 2 mm thick. See, this air 2 mm thick, that means how much thick? 0.002 meter. And ammonia here, that is diffusing. So let me read. Conditions are such that the gas contains 50% by volume ammonia. So the gas that is here is component 50% ammonia. Okay, that is diffusing. At one boundary of the stagnant layer, one boundary, that means here it is given here value at one boundary. Okay, the ammonia diffusing to the other boundary is quickly absorbed. Here quickly absorbed, that means at this side the value is 0 because it is quickly absorbed. Like some air, suppose they are swept away immediately once ammonia come there. जैसे अमोनिया के बाहर ले गए तो वहाँ फिर फ्रेश एयर आ गई. So 0% अमोनिया यहाँ हमेशा बना रहेगा. And the concentration is negligible, clearly written negligible. So I'm taking 0. The temperature 295 Kelvin, pressure atmospheric, that means 1 atm. Under these conditions, diffusivity is also given. The rate of diffusion of ammonia through layer. Clearly, here this is B stagnant case. Ammonia gas is diffusing through a stagnant air. Clearly mentioned here. Only ammonia is diffusing. So all data is extracted. PA1, okay. What is PA2? Because here 0%, so it's 0. It's 0. Now, what is PB1? PB1 is P minus PA1. What is PB2? P minus PA2. अरे भाई, this side total pressure is PA1 plus PB1, and at this point total pressure is PA2 plus PB2. Total pressure still remain on surface or on the top side. दोनों sides of total pressure तो same ही होगा. We are not dealing pressure diffusion. Only the respective component pressure distributed. Now, just use the same formula. PBLM first you have to calculate beta. After this, you have to put in this equation. PA2 0 here. By using, you will get just calculation, you will get this answer. So 2.577 is the right answer. Okay, 2.57, because here already it is written. So here you have to write only 2.577. 2.577. This is your answer. Again you have to calculate by your calci beta as your homework. सारे के सारे क्वेश्चन जो भी आपको यहाँ कराते हैं रीप्रैक्टिस आपको करना है, so that you will be able to remember these things or techniques for a longer period, at least till gate exam. See, gate 2023 beautiful PYQ question. Here they are asking just the ratio Na, unimolecular diffusion, and equimolar. Unimolecular means B stagnant case. So you know they are asking just about drift factor value. This is drift factor in terms of YBLM, P by PBLM, P by P, PBLM by P. So 1, both side if I am dividing here P, here P. So this is P by P1 and PBLM by P, it is YBLM. So just Y, because why I am converting in YBLM, because here they are asking, they are giving data in terms of, see, mass fraction, mole fraction. Okay, so directly in shorter way I want to calculate. So just YBLM calculated and its reciprocal is going to give us answer. Okay, YBLM I think it will come 0.84902, and after reciprocating it you will get 1.18 as your answer. Again you have to practice this beta. Okay, आपको फिर से practice करना होगा इसे. Okay, so I hope beta everyone enjoyed today's lecture. बोलो, अब इससे ज़्यादा लंबा नहीं करेंगे, 2 घंटे हो गया, काफ़ी है इतना पहले, बिकॉज होमवर्क यू हैव टू री प्रैक्टिस ना. सो टेल मी बेटा, एवरीवन एंजॉयड टुडेज लेक्चर बेटा? सभी को मज़ा आया? Many diffusion cases are still there beta Divyansh, and that I will discuss in next lecture. Still diffusion is not completed. Okay, variable volume or sublimation type, some spherical ball, naphthalene ball, area varying in this manner or area varying in that fixed manner. So many problems are still there that I think we will able to complete in next lecture. बिकॉज बहुत अच्छे से डिज़ाइन आपको किया, आज आपको लग गया होगा कि कुछ भी टॉपिक भी नहीं छोड़ा, 2 घंटे में हमने कितना कुछ ले लिया. ओके, सो एवरीवन एंजॉयड बेटा, सो प्लीज डोंट फॉरगेट टू शेयर दिस लेक्चर विथ योर फ्रेंड्स, एंड if you want a great rank, rank 1, rank 100, any rank between these two, then my dear students, in order to get your dream job, then don't forget, if you want dream job, I must do my revision daily. 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 All the best, beta. Take care. And a very, very happy good night to all of it. I love you all. And one more thing, beta. Anyone, if want to join my complete crash come full course, beta, then feel free to connect on this number. थोड़े से पैसे खर्च करोगे तो मात्र जो ये 2 से 3 महीने का समय बचा हुआ है, विद इन 3 मंथ आपको रैंक 1 के काबिल बना देंगे। बस साथ साथ में जो प्रैक्टिस क्वेश्चन देते हैं, एवरी डे द प्रैक्टिस क्वेश्चन दैट आई एम प्रोवाइडिंग, यू हैव टू प्रैक्टिस। ओके, ऑल द बेस्ट, टेक केयर, a very happy good night to all of you. Slide will be available, PDF will be available in app. Yeah beta, if you can, then one more time you can uh, see this lecture. ओके, रिवीजन टाइप में आपको और अच्छे से रेडी हो जाएगा। राकेश, टेक केयर बेटा।